button. All right, awesome. So Ima, I gave you, you can start admitting people in the room for the next 5 to 10 minutes, but we'll get started. So you guys know the drill. So go ahead and put in the chat your number. This is session 8. So very curious about where do we stand. 1 is for I hate this class. 2, I'm not getting it. 3, it's making sense. 4, I like it. 5, I love it. So let me open the chat. So start putting that in the chat. Also make sure that your name is written the way it is in your registration. That way Ima can quickly provide attendance. Today we have a guest speaker, so let's get going fast. Okay, I'm only seeing like a couple of people writing in the chat. So everybody that is in the class, please put your number. That is how we count attendance too. So put your number so she can mark you present or not. Okay, so I see some 4, 5, 4, 4, 4 mostly. Okay, keep it going. We're gonna move on. Hi, I'm unmuted. This is the moment for you to ask questions. If you have any question about the project, the homework, the quiz, put it in the chat right now. We can discuss that or we can pack it for shortly. All right. So today we have a guest speaker, and our guest speaker is Daryl Ferris. I want us to start quickly with the guest speaker so that we can answer more questions on the other side. Daryl is the U.S. regional CEO at Abrasta. He has a broad skill set that allow him to own complex interdisciplinary projects and able to jump into existing efforts with ease. He collaborates with contributors, stakeholder, executive using their language to distill big idea into actionable plan and execute them efficiently and pleasantly. He has a deep understanding of product, process, motivation, help him craft strategy, mentor, and manage team, and nurture productive relationship. He shined brightest on special project as subject matter expert, strategizing on product feature and delivering and being a conduit between user, business, engineering team. He's a frequent conference speaker on topics related to software quality, cross-functional collaboration, and team building upskilling. Okay, so I'm going to stop sharing, and then I'm gonna allow Daryl to start sharing. So let me make sure that you are able to share multiple participants. Yes, go ahead. So I think we have Daryl with us. So go ahead and start sharing, and I'm gonna make sure that you are spotlighted. Yes.
And that looks good. Let me see if I can get the chat displaying over here as well so I can keep track. But Zoom always makes it difficult. But everyone can see the screen okay? Wonderful. So hi everyone. Today, first, thank you, Lisette. Thank you for everyone for joining. It's an honor to be a guest speaker, and I love these two topics that we're going to talk about. Really, three topics. And please let me know if you have any questions along the way. And always, you can feel free to follow up with me. You can find me on LinkedIn, and I'll put my QR code here. You can scan that or just go to LinkedIn and add me. I love answering questions. And if I can ever be in help in your learning, just ask. So as Lisette mentioned, I'm the US regional CEO for a company called Abstracta. I've worked in tech
Oh,
for over 30 years. That's why I don't have very
if
much
you
hair
guys
left.
are not talking, please go on mute. Go ahead, Daryl. I'll make sure.
Thank you. And I've worked at all sorts of companies in my career. I've worked at some big companies like Microsoft. I've worked at very small companies that you've never heard of. But most of all, I've really enjoyed working in different aspects of software quality. And today we're going to talk about how quality has changed, especially with regards to DevOps. And we'll also talk a little bit about accessibility testing and performance testing and non-functional testing as well. So just to get going, if anyone isn't familiar with waterfall methodology, I like to call it the old way, even though there's still many companies for the fall. But Agile was really the first big change that I experienced as an engineer in my career. And how it relates to testing is very important. If you notice in this diagram, waterfall is a very linear step-by-step process. And so all of this development work is happening at one time. So imagine you're building an entire application or an entire web page, and then you give the whole thing to someone to test. Now, when you give a big thing to someone, right, it takes more time. And then when you make changes, you have to go backwards and then you have to test the whole thing over again. And so it was not efficient and very slow and also frustrating at times. But the main point is that you really only get a big outcome or value at the end of the process. And Agile gave us a different way of doing this. And with Agile, we're basically doing smaller iterations so we can deliver little bits of value along the way until we build something bigger. And that lets us react to change. Sometimes we make mistakes, right? We don't know everything when we're planning what we're going to be developing. So doing things in smaller iterations gives us more time to adjust and learn and ultimately do a better job. And we're also testing throughout these processes. We're not waiting until the end to test. We're trying to test as early and often as possible. So those are the big differences there. CI/CD, or continuous integration and continuous development, uh, made a lot of that automated. So what happened was all of a sudden we started having things be a lot easier for software developers. So they could push a ton of code all of a sudden, and automation made that possible. Now, what happened was is that the testing part wasn't quite ready. And so what happened was testing became a bottleneck. Imagine you're trying to push all of this data into a very small funnel and then get value on the other side or a software release. So, what testing and testers had to do was learn to adapt and also embrace automation so we could participate in those iterative cycles like we see here. And so we could start doing what we might call continuous testing. But CI/CD is wonderful. CI/CD made things so much more efficient. It helps us get more code into our software faster and with less risk. It also eliminates a lot of manual processes. It gives us consistency and repeatability, which is very important. It lets us find issues earlier in the process. And if we find issues earlier, they're usually easier to fix and they're also cheaper to fix. Because the longer you wait, oftentimes the solution becomes more complex. And it also, I think, fostered a sense of shared responsibility and community among teams as well, because all of a sudden we were all participating in the same process at the same time. So we all had the same awareness and the same perspective. And that made teams stronger together, more cohesive. So when you put QA or software testing and DevOps together, all kinds of good things can happen. As I mentioned, right, we get speed, we get consistency. It allows us to collaborate and have a shared view of what the thing that we're building is. And it's all powered by automation. Automation's amazing. It lets us do so many things in so many different ways and areas. So thinking about traditional QA versus QA and DevOps, oftentimes, right, remember testing was its own phase in the project, and oftentimes those testers were just sitting around waiting for a software engineer to give them something to test. Whereas now in DevOps, right, testers always have something to test. The problem is we never have enough time in order to do everything, right? But that's where automation really helps. And it lets us, because everything can happen consistently and in a easily repeatable way, uh, it lets us focus on quality at scale. And scale means many different things, right? But think of scale in terms of software development. You can just do things faster and more efficiently, and therefore you can do more with less. And that helped us deliver products faster. It helps us deliver products with better quality. And it helps us, most importantly, create happy users on the other side. And DevOps is not without challenges as well. Some of those challenges, right, when you speed everything up, sometimes we go too fast. So common challenges, right? We have to think about, especially in testing, managing our test data, managing our tests, avoiding bottlenecks, right? Making sure that the processes that we build and the tools that we use can all work well together. And the people are also working well together with those tools. Um, Best practices when you're doing automation in DevOps and with software testing. Typically, we build automation frameworks. Sometimes we might buy commercial tools or purchase commercial tools to use, and those usually have their own frameworks with them. When you build a framework, it helps you build your tests more efficiently and focus really on the testing. But they're two efforts. Oftentimes, building a test automation framework or solution in code, it's just like building software. So we have to do pull requests and, put in notes. People should review the things that we're checking in. It's really software engineering. Um, Infrastructure as code is really important in DevOps too. It's not just the software we're building. Oftentimes we're provisioning servers, changing firewall rules, and the ability to do all of that in code lets us deploy more infrastructure via code, right? Everything's in the cloud now, so we can do so much with code with Azure DevOps, Google Cloud, all of these things, right? We can interact with these different platforms that host our applications via code as well. And that all works inside the same pipelines. Monitoring and observability, super important. We'll talk a little bit about these two topics a bit more in performance testing, but it's always important to understand how our products are behaving in production and what is our user experience like. Are they, coming to our product and it's really slow? That might frustrate them. Maybe they'll go look at another product and leave us, which is the worst thing that could happen. Um, in terms of DevOps, if you don't know already, technology changes really, really quickly. When I was younger, the pictures that our phones took were horrible, terrible. Now you get a cell phone and you take a picture and it's better than some big cameras. It's really amazing. And that improvement, continuous improvement and adaptability are everywhere in technology. So as people, we have to be really good at learning new technologies, understanding how to learn new technologies, and I bet Lizette is really good at that part. And the other aspect of it is adaptability, right? Things change. AI is the big thing right now. When I was younger, the internet was the big thing that we all had to adapt to. Um, it's kind of amazing to think that we have so much access to information now that we never did before. Shifting over into performance testing, should we pause for questions now? If anyone does have questions, just put them in the chat and I can address them as I see them pop up as well. So thinking about non-functional testing, right? Functional testing is typically what we think of when we do software testing, but there's so much more. So let's jump in and talk about that really quickly. So what do we mean by non-functional? Non-functional testing evaluates the quality attributes of a system that focuses on how it performs, not necessarily what it does. And so we'll talk a little bit more about that. But functional testing verifies functionality. It specifies, what does a user do? Can I log into the application? Non-functional testing covers a few different areas. It covers the performance of the system, the performance of our applications that we build, the infrastructure, things like usability. Can a user accomplish their goals in our product quickly? Accessibility. Can people with different disabilities or needs access our applications and get value? Reliability and security, super important nowadays, right? Everyone's getting hacked and everyone's information is getting, shared out across the internet. And in some countries, you can be fined by governments if that happens. And then what happens then? All the money for your business goes away, and it's a big problem. So we have to also be focused on security, accessibility, all of these things in order to have a quality product. So as an example, a functional test might check whether a user can log into a website correctly, right? If I type in my username and password, hit the button, am I logged in? Non-functional tests of that same thing, right, might look at how quickly does that login page load? How much time between pushing the login button does it take for me to actually get logged in? And that's the first thing a user sometimes does when they come to your application, right? So if that's a bad experience. Maybe they're like, "Oh boy, no, this is all going to take forever," and so it sets up people's expectations to expect more slowness, and that's not good. So thinking about different types of non-functional tests a little bit deeper, performance testing, which we'll talk a lot about in a little bit. Performance testing looks at how responsive our app is, what's its general speed, how quickly does it respond, and if a lot of users hit the site at the same time, what happens? Sometimes on holidays, if we think of e-commerce sites, sites that sell things, Sometimes on holidays, it's big shopping days. One here in the United States is coming up in a few weeks. And that's usually when you see all sorts of websites having problems because all of a sudden millions of users are coming to it at the exact same time. And all kinds of things could happen. So as testers, we can we can basically test that, right? We can generate synthetic or fake users to do things on our websites via automation so we can predict how it will react in the real world when this really happens. And usability testing, on the other hand, is, how user-friendly is it? Things like navigation, look and feel, is it enjoyable? And security testing, of course, looks for things around data protection, access control, right? If I'm a normal user, can I somehow access admin functions, right? Hopefully not. All sorts of bad things can happen. We want to make sure that user data remains private. There are laws against that in certain countries. So there are legal reasons why we do this as well. And then accessibility testing. Accessibility testing focuses on people who have special needs and make sure that they have ways to do things in our products, get value from them, right? If you're maybe colorblind, uh, different colors, right, can look very funny. Oh, someone drew. And colors can look very funny, right? So we have to make sure there's good contrast for things. Screen readers, people who are blind can use the internet as well, but we have to do things to make that easy for them. Do, 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 do.
Let me see how to fix that.
I was
Just
just
go.
looking for it too.
No, no worry.
All
I
right.
I don't
I
know.
love modern art, so it's okay. Um,
Go ahead.
So digging more into performance testing. Performance testing, right? What is performance? What do we mean by that? Performance considers the amount of useful work based on the time and resources used that we can affect in a certain amount of time. Performance is a non-functional requirement oftentimes. Um, and it basically lets you be proactive about ensuring the quality of your system through its performance and non-functional aspects. Um, we can also detect errors that might only happen when our sites are under a lot of load. So we have to create those conditions so our users don't realize it before we do. We always want to know these things first. We don't want our users finding our bugs for us. That'll just make them have a bad experience. So a few bits of vocabulary that we'll talk about here. So an environment, you probably already know what an environment is, but we're thinking a specific test environment that we might have configured in a certain way to facilitate the ability to run performance tests. Um, Load, we can think of load as like the number of users or the amount of traffic that we're generating that we're going to try to direct at our application. A test case, this could be uh, anything from, the site should respond within, X number of milliseconds, or it should return certain error codes when it reaches a certain threshold of some sort of error. What are the expectations that we have on our application? Virtual users, this one's easy. They're virtual users, they're fake people. Essentially, we're creating browser sessions oftentimes or API calls that we just direct to the application, a lot of them at a time, and then we can track the responses of the application and get a sense of what that experience might be like for users. Ramp up time, we'll see this in a graph, I believe, but ramp up time is sort of how quickly do you want that big load to hit your application? Is it immediate? Do you want to do a little bit, level off, a little bit more, level off? There are lots of ways you can configure that. and reasons why you want to do it in different ways. Think times. What a think time is basically a pause in between the actions that your virtual users do. And that's to simulate kind of how normal users would, right? When I go to a website, I wish I could, but unfortunately I can't just, click, 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 click and do everything super fast. What think times also do for your performance scripts is it sort of randomizes a little bit the time that all of these different calls are hitting your application. So it makes it a bit more real world. A baseline is, what's the expectation that we have given a certain load, a certain number of virtual users, etc. Response time, how long does it take for the website to respond under load? Sometimes, most times, as you increase the load, your server can slow down, right? And that's when we want to make sure that if we're running auto-scaling architecture, that our servers are, either opening up a new instance or expanding their processing ability to handle that additional load. And then throughput is how much data can we get through at one time without it slowing down. And then errors, of course, when things go wrong. 90 percentile is kind of where we want to be. So here's some graphs that I think might be a little interesting, right? So in a load test, at its simplest, we just scale up a bunch of load over a certain period of time, and then we ramp it down. A stress test is, think of it like we're trying to see what the breaking point is. So we'll start a little load, start a little more, and we just keep going higher and higher and higher until something really, something happens, something bad happens. An endurance test, on the other hand, is we ramp it up, we let it run for typically a longer time, and we see, can the app handle sustained load over time? Scalability, this is, where we're thinking about, does our infrastructure, handle things well? So again, we might scale up a little load, scale up some more, and then, let it sit down and when we start seeing errors happen. And what we're trying to figure out is, what is that line? When do things go bad? And are there things that we can do to change that and make it work better under heavy load? And a peak test is interesting too, because this lets you see how your application responds to spikes in traffic, right? So imagine Sony just released the new PlayStation 5 Pro, and everyone, who can afford one wants to buy one. And so all of a sudden, you just have these spikes of traffic. Maybe it's available in my time zone at 5 p.m. Maybe it's in your time zone at 6 p.m. And so every hour you get this spike of traffic. So all sorts of things, different scenarios that you can mock that way. So why performance testing? We might do performance testing regularly, but oftentimes we do it when we have changes in infrastructure, right? Maybe we change out a service. We want to make sure that the application is behaving in the same way. New versions, new features, again, changes in architecture. If we're trying to optimize systems, I like doing performance testing in some sort of regular interval. So we keep tabs on what our baseline of performance is. And we know that if we're making changes, how is our product impacted? We'll speed through some of these slides just to be mindful of time. But remember, when we say infrastructure and architecture, there can be lots of things in the middle, right? It's not just the web browser and the server. There's also internet speed, right? So how does your application perform on your cell phone, on your cellular network versus Wi-Fi? What about all the different firewalls and content delivery networks or CDNs, different servers, right, that your application might be calling to create ultimately a view that the user can see? And then, of course, all of that other stuff in the back end too. Web applications can be very complex. So we want to make sure that we have monitoring tools in these places so we can see when things do slow down, which part? It could be anything. So we have to have good visibility into our system so we know that we're not just running a test to figure out that when a lot of users hit it, it slows down, but when and what specifically is slowing down. Because if we know that, then we can go try and optimize things and make them better. So some things to keep in mind when we're choosing what to automate, which is always a question with any kind of automation. What should we do? Um, Always remember you can never test everything, so don't try. It will just frustrate you. Um, when you think about what should we test, right? What things are most used most often by your users? What things consume the most resources as well? That could be a vulnerability. Um, are there certain processes or business logic in our application that are really important? Imagine if you're an online bank and you're trying to pay a bill, right? Your customer wants to come in and pay a bill. If something is wrong in that system, maybe that customer gets a late fee because their payment never arrived. Now you have an angry user, and you probably owe them money. So think about risk there. And what are common performance test components made of? Uh, Typically HTTP requests because we're often working on the web. Whatever test data that we need, assertions, right? What are we actually checking, or what do we expect or not expect? Oftentimes these are error codes, like a 500 error. You know, when you see a 500 error, that means something's really, really wrong. And think times, right? How do we want to structure the calls as they go out? How do we want to send all of that traffic to our applications? And when we're thinking about the load part in particular, the actual traffic, what are we trying to simulate? How long should this run? What kinds of tests do we want to run? And what kind of test data that we want to use? And so, and most importantly, what's the acceptance criteria, right? If we start getting errors really soon, that's much worse than getting errors, at a much higher load. Because naturally, right, if you have errors when you have a small load, you probably have a very weak application that might not be ready for broad use by customers. When we think of test data is super important as well and often challenging. Getting the right data for our tests, sometimes easy, sometimes not. But if we're getting data from existing databases, right, maybe we have in production a database, we copy that down. We have to make sure that we're not using personal information from people, right? Again, if I'm a bank, I don't want people's credit card numbers. I don't ever want to see people's credit card numbers in my application ever. So we have to obfuscate or hide or mask certain bits of data. Sometimes we might have to convert formats. We might duplicate records, if we just have some records that we can duplicate over and over again to generate data. Sometimes that's easy too. But sometimes either we have to, or maybe it's just easier to generate data as part of our tests. And there are lots of tools to help you generate data. Some of that can also be scripted. So in your CI/CD pipeline, you could potentially have a script that populates a database with your test data before running your performance tests. So again, all of these things can be automated. Acceptance criteria, the essence of every test. What is acceptable? What kinds of response times from our servers have we decided are okay? What percentage of errors from calls is, what's our baseline? What's the threshold? Um, that stuff's kind of confusing. But thankfully, some really smart people have put together a model called Rail. And that lets us kind of give us some categories, right? If we have a less than 100 millisecond reaction time, that's okay. If we have over 1,000 milliseconds, right, users are going to lose focus. They're going to think something is wrong. So we typically try to get things as low as possible, right? The faster, the better. These are a list of some common tools. There are many more. There's a new testing tool being released every week. But some really common ones, JMeter. JMeter's been around forever. It's also a very common format that you can convert to and from. So a lot of commercial and open source tools can work with the JMeter format. Gatling also is there. BlazeMeter is a commercialized version with some extra things of JMeter. Lots of tools out there. Um, when you are kind of doing it yourself, and this is the way that I started out, I used an application called Fiddler. There's another one called Charles, and you can also just do this in your web browser now as well, and which is wonderful because that's free. And what you want to do is basically look at calls in your network tab in Chrome DevTools, and you can see the different calls that happen, when you load a page. What I often do is, and I'll show you this later, is open a web page, open Chrome DevTools, hit refresh, and then I look at all of the network calls that are happening. It's amazing how many different components and pieces go together to make just a simple web page. So make sure that you have all of your tools in place. Make sure you have monitoring in place when you start, building your tests, because again, we want to know what our machines are doing. Pardon me, when we test them. 1 second. Take a sip of water. When we think of user behavior, if we want to try to add some realism to our test, right? Think times again, how do we space in between the actions that we're doing? We want to make sure that only necessary steps are being executed. So you don't necessarily want to log in, authenticate a user and then continue trying to authenticate that user over and over again. A normal user would never do that, and it's probably just going to give you errors anyway. So be thoughtful about how you structure your tests, always. Functional, non-functional. Weighted test steps. What this lets you do is what calls are you putting in your tests that are most important, right? So authenticating, very important. Maybe setting a filter is less important. If you say, check a box, that'll send a call. So it basically lets you later on when you're looking at reporting, say, oh, the most common errors are on our most important services. So this is a very big problem. Or opposite, right? All of our important or high weighted tests, those are all working fine. It's just these less important tests where the problems are. So there's less severity of the impacts there, which is a good thing. Assertions, we always want to make sure that we're getting the responses that we expect. So oftentimes, we're looking for success or failure, sure, but we want to know why. And so oftentimes the response codes, response times, those are clues as well as good information on their own. But oftentimes you can see response times start creeping up, and that lets you know that, okay, we're approaching something. So that's where observability really helps as well too, is watching how your applications are behaving while you're executing performance tests against them. And as I mentioned, right, the analysis portion, reporting, all of that stuff is great. So make sure that you have your hardware considerations, your infrastructure. That could be cloud, it could be local or on-prem. It just depends. But make sure you have all of your considerations there, load generators, you've got the right network connection set up. You have a valid test environment, ultimately. monitoring. I keep talking about it because I think it's so important. Um, you have to make sure that you know what your system is doing when it's under test, because that helps you understand why, and then it helps you understand how to make it better, how to fix it if there's a problem. So these are things at the application level, right? Is there a certain database query that's taking a long time compared to other database queries? It could be your application server themselves. Or it can just be more things like, with our laptops or computers, sometimes if they have low memory or a memory leak, we can see that in observability tools. If we're running out of disk space, that can cause all sorts of problems as well. If the CPU is spiking or the CPU temperature is at an elevated level for too long, that can have lots of negative impacts as well. Network throughput, and of course, errors from your application as well. If every time I load the application, it's got all sorts of bad things happening in the background, guess what happens when thousands of users hit that application at the same time? It makes more errors, and that can slow things down as well. So monitoring your application, monitoring your infrastructure as you're running your test can give you so much more insight and help you resolve any problems much, much faster. So thinking about the execution side, right, running our test, it's so much fun. Make sure we understand what our expectations are, and that's what we mean by baselines, right? What happens if we run this test with a single virtual user? What happens with 100 virtual users? What about 1,000? Measure all the performance, get your metrics, understand kind of where things are at those levels. Because then as you add new features to your application or you change bits of architecture, you can understand, did something change? And that's why the baseline is so important, because you can understand, where that change occurs. Not all change is bad. Maybe all of a sudden change some things about your product and your application, and your application starts running better, right? It's more performant. And that's a good thing. We want to know. That's something we should celebrate as a team. And so it's always good to understand, again, what are your expectations? Always keep track of the information that you get. Most times we have tools that do that for us. Sometimes we have spreadsheets that we make that do that for us. But we want to track the data that we generate from these tests. So again, we always know whether we're making things better or making things worse. Um, these are some other tips on the side. We don't have to go through each of them individually, but we'll also share the deck after too. But again, I want to point out number 8. I always think it's a good idea to have a human in the loop being our CI/CD process, right? When we generate errors or data or success or failure messages, someone should be paying attention to that. And we have to approach solving these problems as a team. So this is where tools like Slack or Microsoft Teams can also come in handy and automate some of those messages that we would see coming out of these systems as well. When we're thinking about looking at those results, I think it's really important to make sure that you have information about the system you're using, right? If you're using web browsers or just API calls, we want to know if there are any problems on the client side as well as the server side. If there are different tests you can do for that. Um, Always pay attention, look for patterns. It's the last bullet point, but it should probably be the first one, because oftentimes, especially if you have graphs, right, you can see patterns. Oftentimes, seeing a visual of it is easier than looking through a bunch of different errors. Graphs really, really help in performance testing, because you can track essentially, where your load is and then what the response is from your application visually. And it makes it easier to see things. All right. Moving into our other non-functional topic today, we're going to talk about accessibility. Accessibility is a very, very big topic. Today, we're going to focus more on what I would term web accessibility. Accessibility can have lots of physical devices as well. But today, we're going to talk more about standards for accessibility as they relate to the web. So accessibility lets us ensure that our products, our applications are usable for people who have certain types of disabilities or special needs. And it's really important for a few reasons. One of them is that people with special needs actually make up a pretty large portion of people on the internet, right? And as a business, I want as many people as possible to be able to use my applications because that's how we make money. And on the human side, uh, we just want to be inclusive, right? We want people with special needs to have good experiences with technology. We want people to be able to use technology. I think of my parents now, they're very old. But I know that if my mom falls down in her house, she can just say, hey Google, and call Daryl, and it's going to call me and let me know. So I want to make sure that, the microphones on these devices work. They can pick her up if she's far away. So there are hardware concerns, with all of this too. Um, the main categories for this, there are more, but it's primarily visual. Auditory, meaning like your ears, right? People can be blind, they can be deaf, or have hearing loss. Um, they might have cognitive abilities. Think of dyslexia. And there are certain fonts or typography that you can use that are easier to read by people who have dyslexia. Motor impairments, right? Maybe it's very difficult for me to double click very rapidly because I have arthritis. Or one of the most interesting examples was a man who's in a wheelchair. He cannot move any part of his body below his neck. And so what he has is a little straw, a little tube that is by his mouth. And basically to click his mouse or do things, he uses his tongue, almost like a mouse button on this thing. So I'll do this. It looks funny, but he's like, and that's how he works his computer. It's amazing because otherwise, right, how would he do it? Somebody probably told him that he would never use a computer. And then someone made or invented a device that allows him to not only use a computer, but to have a job and earn money, right, through using technology. So accessibility can really impact people's lives in many, many ways. Um, Accessibility, there are standards and guidelines that help us create accessible products, accessible web applications. The most common one that we use, or common standard, is called WCAG, WCAG. And these are all things you should Google. But WCAG has different levels, A, AA, AAA. So it kind of can be, you're accessible at this level, but you can also be more accessible at these other levels. And the reason why it's multi-stage is so you can start somewhere and start doing better things, and then ultimately become, even more robust in your approach to accessibility. Section 508 and the Americans with Disability Act, these are specific to the United States, and they help us with other guidelines to make web applications more accessible as well. There are also international standards for this, certain European standards. I think WCAG is probably one to focus on. I think most other things are sorts of subsets of it, if I'm not mistaken. And the reason why we do this, I mentioned before, right? I talked about how we want people to use our applications. There's a business reason for this too. There are also legal reasons, especially in the US and Europe, particularly in the US. Um, the government can basically fine you if you're not compliant, if you're within a certain industry. So here in my country, healthcare, banking, those have to be accessible applications to a certain standard. Or a disabled user who's a customer of that company can file a lawsuit or sue that company. Um, and no one really wants that to happen, right? So how do we incorporate accessibility into our development practices, right? There are ways to build accessible applications. And oftentimes those also make the applications better for everyone. So it's a good thing. Different ways we might perform accessibility testing. We can do that manually. There are assistive technologies, as we call them, like screen readers, voice navigation, the ability to use your keyboard. I don't have special needs, but I love websites that I can just use my keyboard to navigate around, right? Hitting the tab key, space bar, enter key. Sometimes you can get around things really quickly that way. There are automated tools. One is called Axe. Lighthouse is built right into your web browser. I can show you a little demo of that really quickly. Um, User testing, oftentimes this is crowdsourced testing as well. So how do you get real users to give you feedback about your application? And oftentimes a combination of these leads to a good strategy. Some common issues that we often find in applications when we're looking at these aspects of them. Visual impairments. In HTML, there are attributes that you can add to HTML elements like alt text or title tags, ARIA attributes, ARIA. These are all really important ways to um, decorate your code to make it more accessible. And this is really important for things like speed, screen readers, or text to voice. People with hearing impairments, right? Do you have captions in your videos, transcripts of audio, right? Maybe I can't hear, so I need to see the words. Motor disabilities, I have a particular application on my own computer. When I have my monitor in a high resolution, the application doesn't scale. So the buttons are this big instead of normal sized. And so it's really hard to use like that. So making sure that uh, the size of our UI elements, right, make it easy for people, who might not have super precise motion, right? My father has Parkinson's disease, which means his hands shake when he's trying to use the mouse. So bigger buttons make it a lot easier for him to click the right thing rather than small buttons. Complex navigation, bad instructions, when you're signing up for a website, having too many things on the screen, that can overwhelm people who have cognitive disabilities, right? So how do we keep things simple? And this is something that some application manufacturers do very, very well, right? How do you have very simple UIs that let people do the things that they need to do in a quick and efficient way? It often looks better too from a design perspective. Um, so just to kind of recap some of those solutions I mentioned, right? Semantic HTML, meaning, good HTML structure. A lot of accessibility concerns are really handled at the HTML layer. So understanding ways to make elements more accessible is pretty easy, actually. And it's a really easy way to start building your applications with accessibility in mind. It really doesn't take a lot of work to do it. Um, Again, it's pretty easy stuff. You just have to be consistent. Alt text is another thing on the HTML side. Alternatives to media, right? So making sure that if you have videos on your website where it shows someone talking, uh, can we have some captions or subtitles there? Um, you see this a lot more on websites now, but having a feature to increase or decrease the text size or scale the UI to make it bigger or smaller, that can help people who have eyesight problems, like me. So good practices here. Early testing, if you incorporate accessibility checks early in the design phase or think about accessibility in the design phase, that'll help you build a more accessible application. And it also gets the rest of your team thinking about accessibility. So people will find issues sooner. Real world scenarios, I think, are very important as well. You can certainly automate certain types of accessibility testing, but always make sure that you have certain users that you can rely on to give you good feedback. At my last company, we received a message from a blind user, a user who can't see. And he said that he can use most of our application, but told us the specific areas that they were having a problem with. And it helped us focus our effort and make that user a very happy user. It was also really cool to know that we had someone using our website who couldn't see, and they liked it. Yeah, it was really awesome. Um, because you're automating accessibility, you can also put this in your CI/CD pipeline as well. And so much like performance testing, right, you can start doing these things iteratively and keep track of them. Accessibility is an ongoing commitment. Everyone has to commit to these things if it's going to work. And I think it's also if you get appreciation from it, not only from the tester side, right, but your product team also needs to think about this as well. And if you happen to work in banking or healthcare or finance, chances are your legal team would appreciate your effort as well in this. Lizette, how much time do we have? Not much. All
Not much.
right,
But
let me
what
skip the.
did you want to show up something? I think you wanted to show something, right? Go ahead.
Yeah, very, very quickly.
Yes.
Just in case no one knows what Google Lighthouse is, it's in your web browser. So if you this is a website for a conference that I hosted in August. If I go here and go to inspect and open up Chrome DevTools, Lighthouse is where you can do some very basic accessibility checks without having to install any of the other tools. So I always select desktop, check all the boxes, click Analyze Page Load. What this does is reload the web page, and then it starts running a bunch of automated checks in the background. And within a very short amount of time, you can get some information about, I focused on accessibility with this one. And and you get results and it'll tell you, right? What are my problems here? If I go right to the accessibility section, oh, look, I missed an alt tag on a few images here. And so all I need to do to fix this and probably get this up to 100 is go edit 3 elements in HTML and add probably 30 characters. And that's all I would have to do. So it's great that these things are in here and you can start playing with accessibility and learning more about it just by going to well, let's not go to CNN. It's a bad news day in the United States. And why? But I still went to Google News. I can't help myself. But again, all you need to do is close DevTools, reopen it, go to Lighthouse, analyze page load, and now we
So
can see.
Lighthouse is it part of Google or is it a plugin that you have to add?
No, it's part
So,
of it.
oh,
You don't have to download or install anything. It's just
cool.
there.
Okay,
Yeah, it's
okay.
super cool. Because quite honestly, some of the accessibility tools can be a little complicated. And
Yeah,
they
because you have to install something, you have to like tab. There's a lot to do. So they
exactly.
kind of like automated accessibility for you through that too. That's awesome. Okay.
Exactly. And it's an inspiration, right? And
Yes.
if you say, "Oh, look, we got a 90. What do we have to do to get a 95?"
Yeah.
And usually it's not a lot of work. You just have to focus on it.
That's wonderful. That's wonderful. Is that
Yeah.
it? Are you done?
I'm done.
Oh, awesome. Thank you so much. This was
Pleasure.
amazing. This was definitely insightful. You gave us a lot more information. So yeah, ladies, mostly ladies, go ahead and ask question. Let me see. Okay, just one question. Kaylee, yeah, go ahead. Open your mic or type it down. Let's hear. We'll stay for another 5 minutes and then we can depart.
Great.
Good day, ma'am. Good day, sir. Thank you
Okay.
for that. That was a really interesting lesson. I'm interested in knowing how the lighthouse, since it's able to test if there's anything wrong with the accessibility, how does it go about doing that, especially with accessibility points such as your cognitive disability, your motor disabilities, and your hearing? How does it go about doing that?
It does not really do much on the hearing side, specifically, or motor disabilities. It's really more about the web standards. So that WCAG standard that I talked about, it's really testing against the recommendations from that standard. Is that helpful?
Yes, yes, that was clarified. Thank you.
Wonderful.
So
Yay.
what that mean, does that mean that, when you use this tool, you still have to do a little bit of manual, inspection
Exactly.
to make sure that, those part of the disability piece are covered.
Yeah, absolutely. And there are, I think both Windows and Mac now have screen readers built into the operating systems. So at the code level, right at the HTML level, you can make sure that all of your tags are there and all the things are supposed to be there. But someone should still load the screen reader and make sure that it's actually working. Um, yeah, I think it's always important again to have a human in the loop. Um, but I bet if I Google this, here we go. Here's a link. Mercy has obviously was paying attention and learned, and now she's becoming the teacher. Bravo.
That's
That's
what
what
we
we like.
like.
It is what we like.
Exactly. All right. One more question before we depart. Thank you so much, Daryl. This was fantastic. Fantastic, as
Wonderful.
always. Thank you
It's
so
an honor.
much. Yes, I did not ask you if it was okay to record, so I hope it was okay. You
100%.
approve. So
100%.
yeah, so it's gonna be on YouTube shortly by end of the day. I can send you a link, but I'm sure you guys learn a lot, because we went from like CI/CD, DevOps to non-functional testing, performance testing, and then we learn on accessibility and the various tools you can use. So I think you covered the gamut. So I'm super grateful. So if there's no any more question, let me look at my slide here and see what else they have. Okay, we'll talk about homework on Friday. So everybody checking in on Friday. We did learn a lot. It was a great session. Yes. So and as Daryl mentioned, his LinkedIn is wide open, so feel free to connect with him if you have any other question. We are grateful to all our speakers. They're always a great partner to our program, so we're really excited about that. So I'll see you all on Friday for the project time. So don't miss that because we are counting also attendance. All right, perfect. Thank you. So Ima, make sure that you take everybody attendance before I close the class. Give me a thumbs up before I close the class. I'm going to stop recording all this.